The comet known as 3E Atlas is unlike anything astronomers have tracked before. Most comets follow a predictable path, gradually brightening as sunlight heats their icy cores. But this visitor from interstellar space has broken nearly every rule in the book. Its brightness doesn't follow the smooth curve of a natural body. Instead, it pulses, sudden rises and falls as though breathing in regular intervals. At the same time, it has unleashed strange outbursts that appear too structured, too consistent to be random. Even its chemical fingerprint defies expectations. Where most comets reveal water as their primary component, 3E Atlas is dominated by carbon dioxide. Alongside this, observers have tracked unusually large, slow-moving dust grains that resist conventional explanations, as if the comet were shedding material with deliberate restraint. But perhaps the most striking feature is its persistent emerald glow, a green halo that refuses to match any common cometary chemistry. Taken together, these anomalies have pushed some scientists into uncomfortable territory. Words like engineered probe and reconnaissance object have surfaced in whispers, not as conclusions, but as questions science cannot yet dismiss. For now, the comet is forcing us to consider the possibility that what we're watching is more than just ice and rock. That possibility becomes even more pressing tonight. As 3E Atlas approaches Mars, Earth's vantage point is about to vanish. Our planet will lose direct sight of the comet for days, leaving only the robotic explorers orbiting and crawling across the red planet to carry the burden of observation. Mars orbiters such as MAVEN, Mars Express, and the Trace Gas Orbiter have been tasked with high-frequency monitoring, capturing changes in brightness, dust activity, and radiation. Even surface rovers, if conditions allow, will serve as witnesses, logging variations in light and charged particles sweeping through the thin Martian atmosphere. This rare alignment transforms Mars into more than just a silent bystander. It becomes humanity's outpost laboratory, the only set of eyes capable of recording the comet's closest approach. For astronomers, this is both exhilarating and nerve-wracking. Every bit of data, every delayed transmission relayed back to Earth could either reaffirm the natural explanation of a volatile rich comet behaving strangely or push us deeper into the realm of the unknown. For all the excitement and unease that 3 Atlas has stirred, the scientific community remains careful. Most researchers, when pressed, will emphasize a conservative explanation. To them, this is likely a natural comet, just one born in a colder, more distant system than what we are familiar with. A world where the balance of materials is different, leaving it rich in carbon dioxide rather than water ice, and filled with heavier grains that survive the violent journey through interstellar space. Its irregular bursts of light, they argue, could come from subsurface pockets of volatile ices blowing open at unpredictable times. Even the strange geometries of its tail might be nothing more than heavy dust interacting with solar wind and magnetic fields in ways our models don't yet fully capture. This cautious view reflects an important truth. Science progresses by exhausting the natural explanations first. It is always more responsible to assume that the unknown fits into physics we don't yet fully understand, rather than leaping immediately into extraordinary claims. And there's no doubt that 3 Atlas offers plenty of natural puzzles worth solving. If this really is just an unusually volatile carbon-rich comet, then studying it will expand our knowledge of cometary chemistry and interstellar geology. The mainstream view isn't dismissive. It simply demands patience, discipline, and proof. Yet, even as this careful interpretation dominates the official narrative, 3 red flags refuse to fade quietly into the background. The first is its trajectory. Most interstellar objects enter the solar system on paths that are steep, cutting sharply across the plane of the planets. But 3I Atlas hugs this plane closely, moving as if it chose the most corridor-like route through the inner system. That alone doesn't prove intention, but it makes astronomers shift uneasily in their chairs. The second red flag is the pulsed brightness. Unlike the steady increase of light caused by solar heating, 3 Atlas seems to breathe in intervals. Its glow rises and falls in patterns that have been matched by microaccelerations. Tiny but measurable changes in its speed and position. Independent data sets confirm this. It's as if the object is adjusting itself, nudging its trajectory in subtle bursts. Natural comets don't usually correct course. And then comes the third, perhaps most unsettling anomaly, its chemical signature. Multiple observatories have reported extremely high ratios of carbon dioxide to water alongside occasional spikes of metals that aren't expected in such abundance. These readings might be explained individually by quirks of formation, but taken together, they form a pattern that is hard to dismiss. The combination of unusual flight path, pulsing accelerations, and strange chemistry has pushed even cautious scientists to admit quietly that 3 Atlas may not be just another natural wanderer. This tension between the comfort of the familiar and the pull of the extraordinary sets the stage for what comes next. Every new observation, every packet of data from Mars will either reinforce the mainstream view or add weight to the growing suspicion that something else might be at play. As night falls and 3 Atlas approaches its narrow encounter with Mars, scientists know exactly what they must look for. The comet's behavior has already defied easy explanations, but tonight offers the chance to gather the kind of evidence that could settle debates for decades. Above all, there are 3 key signs that will dominate their watch. The first is fragmentation. If the comet breaks apart under the sun's heat, the way those fragments scatter will tell us what lies within. A fragile, porous body would crumble into countless small pieces, while sudden massive flares of gas and dust would suggest buried reservoirs of volatile ices. The second sign is trajectory shifts. Natural comets may drift slightly as gases escape, but if 3 Atlas veers from its predicted path more dramatically, the cause will be scrutinized. Asymmetric mass loss is one explanation, but if the shifts align once again with those puzzling brightness pulses, the whispers of internal forces at work will grow louder. And finally, the third sign, anomalous spectral lines. If Mars orbiters detect emissions or particle signatures that cannot be explained by sublimating ice, then even the most conservative scientists will have to rethink their conclusions. Which brings us to Mars itself. Not just an observer, but a laboratory about to be tested by an interstellar visitor. The red planet's thin atmosphere, its patchwork of weak magnetic fields, and the fleet of machines we've placed there make it an ideal stage for interaction. If fragments from 3 Atlas brush the upper atmosphere, they could seed temporary auroras that ripple across the Martian skies. They could disturb the ionosphere, creating measurable waves and shifts in charged particles. Even dust deposition might occur, subtle but traceable in the data collected by orbiters like MAVN and the Trace Gas Orbiter. Yet the implications go further than atmospheric physics. If the comet carries complex organic molecules, long carbon chains, or structures resembling primitive biological material, then some of it could settle onto Mars's surface. That possibility raises a sobering concern: whether discoveries of potential organics should be treated as a shared global heritage or locked behind the interests of individual nations. Mars for these few days becomes more than a world under robotic watch. It becomes a crucible where the mysteries of an emerald comet may leave fingerprints that last far longer than its fleeting passage. From tonight's watch and the days to come, 3 possible scenarios rise above all others.